Hello, videos on expectation algebra, mainly seen S3 with combining independent variables. So combining variables. So classic example here would be here that I've got two variables x and y, and we combine them, so we sum them in this case to get z. So an example here that I think in the textbook is Z will be the length of a cricket bat, and it's made up of the length of the handle and the length of the blade, and each of those varies a bit, and therefore you're trying to work out what the expected value in the variation is in the total length of the cricket bat. But of course we could do the difference of the two variables, or we can make any linear combination of them. So what I'm going to do today is go through and remind us how we did this in the sort of S1, S2, which is called linear coding, and then move on in the later videos to look at two independent variables and putting them together. So let's start off with the linear coding, linear transformation. So this is what we would have done in S1, S2, wouldn't we? When we've got some relationship y equals ax plus c, and we know what the mean value of x is, so therefore we can work out that the mean value of y is going to be a times the mean of x plus c. And we can also find that the variance of y is going to be a squared times the variance of x. That's all stuff we did in S1, S2. So let's use this expectation approach to prove what we've just seen there. Okay, so y equals ax plus c, so the expected value of y is going to be the expected value of ax plus c. We then transform that into our probability, standard probability setup, so ax plus c is our variable, and again for each one we're finding the weighted average by the probabilities. So we're doing the probability multiplied by the probabilities and summing them all up. And here we've got our term ax plus c. There's a plus there, so we can split this into two terms. There's our ax term and there's our c term here. And in the first one we've got ax times the probability of x, and a is a constant, and we're summing that, and a is a constant through this summation, so we can bring that out the front. And then we find that we've got the sum of x times the probability of x. When we know what that is, that's the expectation of x. So the first term here becomes a times the expectation of x. Let's have a look at the second term. Well, we've got here the sum of c times the probability of x. Now x again is c is a constant in relation to this summation, so we can take it out the front, and then we're just left with the sums of the probabilities, and we know the sums of the probabilities are 1, so the second term is c times 1, and therefore in summary the expected value of ax plus c is going to be a times the expected value of x plus c. Okay, now let's go on and look at the variance of this variable, and we've got to do this in two parts because we know the variance is the expected value of the y squared minus the expected value of y all squared, and we've just worked that one out, haven't we? We'll come back to that. So let's look at this first term we need to work out, the expected value of a y squared. Well, that's the expected value of ax plus c all squared. And if we drop that into the weighted probability, we get, that's our variable, ax plus c all squared, and we're multiplying that by the probability. It's a weighted average. Expand the first bracket, a squared x squared, 2acx and c squared. Then we're going to break this into three terms again because we've got the pluses here, haven't we? So the first term is going to be there. There's our ax squared, a squared x squared, and if we have a look at that, we've got we can see again that a squared is a constant in this sum, so we can take it outside the sum, and then we're left with the x squared px, which we know is the expected value of x squared. So our first terms become a squared expected value of x squared. What happens to our middle term, our 2acx? Well, if we put that into our middle term here, again that's our our variable that we're finding the weighted average of, and we move again 2ac is constant in the summation, we can move it out the front, and then we've just got the sum of x px, which we know is the expected value of x. So we've got 2ac times expected value of x. And finally, looking at our third term, we've got our c squared times px here. There's our c squared px. Again, c squared is a constant in this summation, so it can come out the front. And so we've just got the sum of p of x, and we know the sum of all our properties is 1. So our final term is c squared times 1. And therefore, we know that our expected value of y squared is a squared times expected value of x squared plus 2ac times expected value of x plus c squared. Okay. Now we've got to find the variance. Now we know this, and we actually know the EY already. So here's our what we just found there for our EY. And our expected value of y we worked out earlier was a times expected value of x plus c. And that's all squared. So if we expand this bracket, we get this set of terms, 3 terms here. And as you can see, they match with these 3 terms here. And we compare them up. So if we take the first term of the first, we get our a squared times e of x squared, and here our first term of the second bracket is a squared times the expected value of x all squared. And we can see if we follow that through that we've got a factor of a squared. We bring that out front, and what we left with in the bracket, expected value of x squared minus the expected value of x all squared. And we know what that is, don't we? That's the variance of x. Okay. What happens to all these other terms? Well, if we have a look here at the second group of terms, here I've got a plus. So let's do this in red. I've got 2ac expected x from the first term here, and over here I've got a subtract a 2ac of e expected x. So they're going to cancel out. And then if I go on and look at my c squared, I've got a plus c squared from the first term, and I've got a subtraction of c squared from the second term. So they're going to cancel out. So what am I left with here? I'm left with fairly straightforward, a simpler version, that the variance of ax plus c is a squared, a variance of x. And that's basically what we proved before in our S1, S2 work, that this was the situation. And of course, what we're basically saying is there's no variation in C, all the variation is in the AX, and we know it's A squared. So there we are. That's the first part, a bit of a revision, but also a demonstration in the new format using this algebra of the expectation and the variance of a single variable linear code. There we are.